So in this video, we're going to take a look at questions 10 through 12. Let's begin by looking at equation 10. We have a radical equation. Particularly, we're looking for when the square root of 5 minus x is equal to 4. So how would we go about doing that? Well, just think about what you would need to be under the square root such that the square root of that number would be 4. Well, what do you take the square root of to get 4? What 4 times 4 is what is another way to say that. You take the square root of 16 to get 4. So what you need is what's under this radical sign or under the square root to be equal to 16. So that's really one way we could go about solving this question. Let me go down to the solution. We could just know that what we need under the square root has to be 16. What's under the square root? It's 5 minus x. That has to be 16. We could solve for x by getting the minus x by itself originally. Minus x has to be 11. We get the x by itself by dividing both sides by -1. And what we find is that equation is true if x equals minus 11. Alternatively, if you've seen this kind of equation before, you probably know that you can get rid of the square root by simply squaring both sides of the equation. If you square the square root, you're left with just what was underneath the square root side, 5 minus x. If you square the 4, you get 16. If you notice, that takes us to that exact point that we kind of did on our own intuition. So naturally, if you solve that, you will get the answer of x equals minus 11, which is B. Let's look at question 11 here. This is another weird kind of question that we necessarily didn't look at. It's a rational equation. X minus 1 in the numerator divided by x equals 20. We want to find what the value of x is. You could just plug all these in and see which one works, but that is probably not the most efficient way to do it. Hopefully you say, well, I just wish that x wasn't in the denominator. And how would you get rid of an x in the denominator? Well, what if you multiply both sides by x? If you multiply the left side by x, that will cancel that factor of x and leave you with just x minus 1. If you multiply the right side by x, that will leave you with 20 times x. So multiplying both sides by x gets rid of the actual rational expression and leaves you with the equation x minus 1 equals 20x. And hopefully you know how to solve those just like a standard equation. Get all of the x's on one side. I chose to move them to the left. If you do that, you subtract x from both sides, which leaves you with just minus 1 equals 19x. In order to isolate the x, we divide both sides by 19, and we get x equals minus 1 divided by 19, which is actually answer C for this. So hopefully everyone sees that. Now for the final question, question 12, let's actually go through and read it. A ball was kicked into the air from a balcony 20 feet above the ground, and the ball's height was above the ground in feet. T seconds after the ball was kicked is given by the equation y of t equals minus 16 squared plus 32t plus 20. So t is the point in time after we kick the ball. It's going to go up, it's going to hit some maximum value, and it's going to come down. And what we want to find is what was the maximum height in feet of the ball above the ground when it was kicked. So this expression, if we plug in a bunch of t's at any time, is going to give us the height above the ground at the point when it was kicked. So let's start by looking at t equals 0. If you plug in t equals 0, both of these two terms go away, and you're just left with 20. Which means when t equals 0, the ball was 20 feet above the ground. And that makes sense, because if you notice, the ball was kicked in the air from a balcony 20 feet above the ground. So we want to find how high it actually goes above 20 before it starts to come down. So this is a pretty tough question, and if you've not seen the concept of quadratic equations before, you might have an issue actually solving it. But what you're looking for is the maximum value of this quadratic equation. And there's a formula that you might have seen before that allows you to determine what that is. And it's called the vertex formula. So it happens if you were to graph the actual height of this ball, it's going to start at 20, hit a maximum value, and then decrease from that. It's going to trace out a parabola. So what we want to find is at what point in time does it actually hit that maximum value? And the way we can do that, we know that if a parabola has the form some number times t squared plus some number times t plus c, where a, b, and c are the coefficients of our quadratic equation, that the vertex, or that point, the time at which the maximum value occurs, is simply given by negative b divided by 2a. So if we match up our equation, notice that a is minus 16, b is 32, and c is 20. So minus b divided by 2a is just going to be minus 32 over 2 times minus 16, or minus 32 over minus 32, which is just 1. So that tells us the time at which the maximum height occurs. How do we find the actual height associated with that? Well, we need to take this expression, which gives us the height at any point in time, and we need to plug in t equals 1. If you plug in t equals 1 to this expression, do your math and be careful, you'll find that 36 feet is the actual maximum height, and that corresponds to an answer of C. And I think we still have, sorry about that, I think we still have to go on in this. I'm trying to rush through this and get it up for you all. Just be patient with me here. Let me make sure. I got a million things going on in the background. I'm sure you heard some of the prior videos, all of the pings and stuff like that. But I think that is actually it. That is the end for this one.